Ancient machines, evidence of technology older than history. Imagine a diver pulling a barnacle-covered lump of bronze from the seafloor, and inside it, gears, fine, interlocking gears, like a pocket watch from a world that shouldn't have had one. If this is possible, what else did the ancients build that we no longer understand? Tonight we go artifact by artifact, separating hard engineering from hopeful legend, to ask a simple question. Did our ancestors wield technology older, stranger, and smarter than history gives them credit for? Welcome back to the channel. In this episode, we're not just admiring ancient wonders, we're reverse engineering them. From precision stonework and lost super materials to devices that look suspiciously modern, we'll examine what each artifact does, what's proven, what's debated, and what's myth. By the end you can decide, are these ancient machines or modern misunderstandings? 1. The clock that shouldn't exist. The Antikythera mechanism. In 1901, sponge divers off Antikythera, Greece, found a corroded bronze mass. Decades later, X-rays revealed something mind-bending. At least 30 meshing gears, inscriptions, and rotating dials. The device predicted eclipses, tracked lunar phases with a pin-and-slot mechanism, and mapped the known planets using complex cycles. In plain terms, it's a mechanical computer from around 100 BCE. What it proves? Greeks possessed precision gear cutting, astronomical modeling, and mechanical design rivaling 18th century clockwork. It wasn't magic, it was math, metallurgy, and patience. What's still unknown, was it unique or part of a lost Greek tradition? No workshop has been found. Takeaway: the ancients didn't just observe the heavens, they simulated them. 1. Concrete that refused to die. Roman pozzolanic concrete. Modern concrete cracks within decades. Roman harbor piers still stand after 2 millennia of waves. Why? A volcanic ash mix called pozzolana, lime, seawater, and aggregates. Recent microscopy suggests Roman concrete self-heals. Lime clasts react with seawater, forming new minerals that reseal cracks. What it proves? Advanced materials engineering and large-scale maritime construction. Optimized recipes tailored to environment. Bridges, domes, piers. Myth check: no, it isn't unbreakable or universally better than modern concrete, but in harsh marine settings, it's astonishing. 1. Steel with a signature. Damascus wootz steel. Medieval blades called Damascus show watery patterns, sharp edges, and resilience. Their secret likely lies in wootz, an Indian crucible steel with high carbon and trace elements. Controlled cooling formed carbide nanostructures that gave blades their bite. What it proves? Metallurgy that balanced impurity control, heat treatment, and carbon content with remarkable consistency. Myth check: it won't slice stone or cut rifle barrels in half, but as engineered steel, it's elite. 1. Water from stone. Nabatean and Persian hydraulics. How do you turn desert into trade empire? The Nabateans, Petra, carved cisterns, gutters, and covered channels that captured every rare drop of rain. Persians built qanats, gently sloped underground tunnels that tapped aquifers and delivered cool water for kilometers with almost no evaporation. What it proves? Large-scale civil engineering optimized for extreme climates. Long-term maintenance, surveying, and governance to keep systems alive. Myth check: not mystic rivers, just brutal, elegant hydrology and logistics. 1. Seismic alerts before seismology. Zhang Heng's earthquake machine. In 132 CE, the Chinese polymath Zhang Heng built a bronze vessel with 8 dragon heads. Legend says when a distant quake hit, one dragon released a ball, indicating direction. The exact internal mechanism is lost, but reconstructions suggest an inertial pendulum or mass that tripped directional latches. What it proves? Abstract sensing turned into a practical alert system. The earliest known attempt at instrumentation of a natural phenomenon. Myth check: it didn't give magnitude or a map, just a significant tremor came from over there. 1. Precision in stone. Inca, Tiwanaku, and polygonal masonry. At Cusco and Sacsayhuaman, citadel walls fit irregular blocks so tight that a knife blade struggles to enter. At Tiwanaku and Pumapunku, H-blocks show right angles and repeated modules with millimetric precision, carved in andesite or sandstone using hammerstones, abrasives, and perhaps copper tools with sand. What it proves? Mastery of surveying, modular design, and vibration-resistant construction in seismic zones. Logistics: quarrying, transporting, and placing multi-ton blocks at altitude. Myth check: no lasers, but yes, jaw-dropping planning and craftsmanship. 1. Power in ash and fire. Greek fire and other lost recipes. Byzantine fleets terrified enemies with Greek fire, a ship-mounted incendiary that burned even on water. The exact formula remains unknown, likely a petroleum resin mix pressurized and jetted through bronze siphons. Elsewhere, Egyptian faience used alkaline glazes to create self-glazing ceramics. Mesoamerican artisans cast rubber balls. Andean cultures colored textiles with biochemical mordants. What it proves: chemical engineering and battlefield delivery systems, not just weapons. Myth check: Greek fire wasn't a flamethrower from a dragon. It was a combined recipe plus hardware system, chemistry integrated with pressure and nozzle design. 1. The Baghdad Battery. Device or misinterpretation? A clay jar, copper cylinder, iron rod. Add an acidic liquid and you can get a tiny voltage. Was it a galvanic cell used for electroplating? Maybe, but no definitive evidence of wires, circuits, or plated artifacts has been tied to it. What it proves: the importance of not forcing a modern explanation onto ambiguous finds. Myth check: fun demo, yes. Proven ancient battery, not so fast. 1. Algorithms without code. Antennas, calendars, and analog computing. Across cultures, calendars encoded astronomical algorithms into architecture. Maya observatories aligned with Venus cycles. Stonehenge marked solar events. Polynesian navigators read swell interference like a living map. These are information technologies, embodied in sky, stone, and skill. What it proves: computation doesn't need silicon. Systems thinking existed everywhere. 1. Why so much was lost? 3 big culprits: materials decay, wood, textiles, and papyrus rot. Bronze gets recycled. Catastrophe: wars, fires, earthquakes, and empire collapse. Transmission failure: trade routes vanish. Crafts become guild secrets. Masters die without apprentices. The result: we see peaks without the surrounding workshop culture. That doesn't mean aliens built them. It means human knowledge is fragile. 1. What ancient machines really teach us. Innovation is cyclical. Techniques are discovered, forgotten, and rediscovered. Engineering is context. The best technology solves local problems with available materials. Curiosity scales. Whether it's a gear-driven sky map or a desert water tunnel, the pattern is the same: observe, model, iterate. So, do ancient machines prove a civilization older than history? Not necessarily, but they do prove something just as inspiring. Humans in every age are engineers. Give us stone, ash, bronze, and time, and we'll build clocks for the cosmos, water for a desert, and walls that laugh at earthquakes. If you enjoyed this deep dive, hit subscribe, share it with a friend who loves history and tech, and tell me, which artifact should we reverse engineer next?